My name is Sadman Binzaman. This is EL6303, assignment 2, question number 2. Draw f of x, which equals 1 minus e to negative ax, times u of x minus c, where u of x is a unit step function defined as equaling 1 when x is greater than 0, or equaling 0 when x is less than 0. Additionally, we're given that a and c are both positive constants. We are also asked to confirm whether or not capital F of x is a valid probability distribution function. Drawing the function is rather straightforward, as we only need to be mindful of the unit step function that does take place. Confirming whether or not the function is a valid distribution function, we need to be mindful of two properties. The first being, if x of 1 is less than x of 2, then is the function of x of 1 less than or equal to the function of x of 2. Our second property asks us, the limit as x approaches negative infinity, capital F of x equals 0, and the limit as x approaches infinity, capital F of x equals 1. Our graph successfully shows that it fulfills both property requirements. We can thus determine that our f of x is a valid probability distribution function. Part 2 of the question asks us to find and draw small f of x, which is the derivative of f of x, capital F of x. We are also asked to verify that small f of x is a valid probability density function. We are given two notes where the sampling property of the impulse function is defined as h of x times the delta x minus a equals h of a times delta x minus a. The delta function is defined as equaling infinity when x is equal to 0, or equaling 0 when x is anything but 0. The probability density function is the derivative of the probability distribution function. In our case, it is the derivative of 1 minus e to negative ax times u of x minus c. Substituting in our sampling theorem, we get that d dx of 1 minus e to negative ax times u of x minus c plus 1 minus e to negative a of x times the derivative of u of x minus c equals a times e to negative ax times the u of x minus c plus 1 minus e to negative a of x times the delta function of x minus c, which equals a times e to negative a of x times u of x minus c plus 1 minus e to negative ac delta function x minus c. Drawing a graph requires us to remember that the area under equals 1 minus e to negative a of c.